Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 2 Algebra. Topic Permutations and Combinations. Subtopic Permutation as an arrangement. Meaning of NPR or P of NR. Permutations in which things may be repeated are not all different. Exercise 7.3. Prove that NPR equal to n factorial by n minus r factorial. 0 less than or equal to r less than or equal to n. The number of permutations of n different objects taken r at a time is the number of ways of filling r vacant places by the n objects. N different objects tagi r objects amuktang lauraga semba yaba permutation gi masing asi r vacant places ta n objects tagi r objects lauraga fill up tawbagi masing aduga managani. The first vacant place can be filled up in n ways. Ahanba vacant place adu n ways ta pangthokpa yai. Adugumba first place adu left tagi obi yai, right tagi obi yai, any place tagi. After this, the second place can be filled up in n minus 1 ways, as we are left with n minus 1 objects, from which we have to select one object, which can be done in n minus 1 ways. After the first two places has been filled up, following which the third place can be filled up in n minus 2 ways. Similarly, the rth place can be done in n minus r plus 1 ways. By fundamental principle of counting, the number of ways of filling in r vacant places can be done in n into n minus 1 into n minus 2 into the dot n minus r plus 1 ways. This is equal to NPR. Again, mathak tasu makha tasu sigi factor asina mathak same factor asina mathak makha su puri dasi n minus r plus 1 dagi 1 less the n minus r ni mangon dagi 1 less the n minus r minus 1 ni asumna n dagi 1 by 1 sum khaidorak labadi last 3 into 2 into 1 lakani hariba angang bana iriba factor si matha makha puri dasi. Hojik 1 into 2 into up to sum lakpana masigi mathak ki sahanga ba factorization asi 1 dagi na n bhawagi puri na bani masidi n factorial na khangna gani. 1 dagi na n minus r bhawki continued product asina n minus r factorial na khangna gani. Factorial gi definition na yaukre. Mathak sidi 1 dagi na up to n fawba continued product of the parts of the natural numbers ni denoted by n factorial. N minus r bhawni 1 dagi na n minus r bhawki continued product of the natural numbers to ni masidi n minus r factorial na denote torani. Hence proof. Note 1. NPN r the NP syllabus NPN is equal to 0 factorial lerani 0 factorial 1 adudi r the NP syllabus icon NPN cd n factorial by 1 di n factorial ga manai. R the 0 syllabus NP note ni masid r the 0 syllabus n factorial by n factorial ni that is 1 ani si khangjan ba yai. 2. Prove that the number of permutations of n objects taken are at a time where repetition is allowed is n to the power r. Karigumba n objects tagi r objects lauraga objects hindu repetition to yarabadi madudagi semba yaba permutation masing si n to the power r na oigani prove to. Solution. Each place can be filled up in n ways as repetition is allowed. Places khudingmakta n ways ta fill up tawba yagani maramdi digit object amana atopa places ta su fill up tawba yai. Therefore, r places can be filled up in n into up to r times. That is n c r times like multiply tawba the n to the power r ways orani. Hence proof. 3. Prove that the number of permutations of n objects where p objects are of the same kind and the rest are all different is n factorial by p factorial. N objects tagi karigumba object amadi p times lag repeat tawre hanjanna yaure lemhoriba object sing adu manadaba ngakta ori madudagi semba yaba n objects mak lawraga semba yaba number of permutations arrangement singi masing asi n factorial da p factorial ni yela phangba value adu oigani praman taw. Let x be the number of permutations of n given objects of which p objects are of the same kind and the rest are all different. X habisina n objects tagi karigumba object ama p times repeat tawba lemhoribasing do amata manadabasing dagi n objects mak lawraga semba yaba permutation masing do x logsilasi. Let us replace the same object by new distinct objects. Sab manaba object ama p times lag hanjanba do adugumba object khuding mak tu new distinct objects atopa manadaba objects singna mahut sindokrasi. In each of x permutations, these p new objects can be arranged among themselves in p factorial ways. Adugumba x permutations sing ki khuding makta p new objects sing adu makoi masen khaktangi manungda rearrange tawbada p factorial ways puthokani amana p factorial ways puthokle. Therefore, x permutations will produce x into p factorial permutations puthoklani. But n different objects taken all together produce n factorial permutations. Kona hana khangkre madudi n distinct objects tagi n distinct objects mak lawraga semba yaba arrangement gi masing di npn, that is n factorial ni. Hojik n objects sing adu loina manadre n objects tu madudagi semba yaba arrangement masing je n factorial permutation ni. Matakta phangkiba x into p factorial ga hojik phangiba n factorial se ani se chap manaba cases ni tongan ba approach tagi puthorokpani. Thus quantity ani se mana halagadi aikoni x to solve toro n factorial by p factorial, hence proof. 4. The number of permutations of n objects where p1 objects are of one kind, p2 are of second kind, pk are of kth kind, and the rest, if any, are of different kind is n factorial by p1 factorial into p2 factorial into pk factorial. Karigumba n objects tagi ahanba object to na p1 lag repeat tawre ani suba object to na p2 times lag repeat tawre asumna k suba object aduna pk times lag repeat tawre lemhoriba posting ado leiram labadi amata manadrabadi madudagi n objects mak lawraga semba yaba permutation masing adudi total number of objects, that is n factorial da p1 factorial into p2 factorial pk factorial singna divide tawraga piba value adu oigani haben. Exercise 7.3. 1. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? 1 dagina 9 phawbagi digit amata hanjalandabida 3-digit number kaya semba yagadage hangmani. 1 dagina 9 phaw digit mapan ni digit mapan sidagi manadaba digit ahum lawraga number kaya semba yagadage hangmani if no digit is repeated. We are given 9 digits excluding 0. I call the 9 digit ni 0 yaugabida. There are 10 digits, but we have to exclude 0. From these 9 digits, we have to take 3, which can be done in 9p3 ways. I call the 9 digit piramle masidagi digit ahum lawgadabani 9 digit tagi 3 digit lawraga semba yaba arrangement masing si 9p3 ways ni. Therefore, required number of 3-digit numbers T 9p3 oigani mana piba value duni. Question number 2. How many 4-digit numbers are there with no digit repeated? 4-digit number kaya laigadage number singda digit amata hanjanba yadavida number kaya semba yagadage. There are 10 digits from 0 to 9. 0 dagina 9 phawasi digit tarane. The thousands place can be filled up in 9 ways as 0 cannot enter here. thousands place adudi 9 ways ta enter tawba yagani maramdi 0 na mafam asida hawba yade 4 digit number dadi. The remaining 3 places, namely the hundreds, tens and units places, should be filled up by the remaining 9 digits, excluding the digit in the thousands place. This can be done in 9p3 ways. Lemhoriba places ahum haibadi hundreds, tens, units place sing adu lemhoriba digit mapandugi manungdagi mapandugi manungdagi ahum lauraga fill up tawbada semba yaba masingdudi 9p3 ways ne. Therefore, by multiplication principle, the required number of 4-digit numbers is 9 into 9p3 ways, which gives 4536 as over number amapiri. Question number 3. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? Piriba digit taruk asidagi 3-digit even number kaya semba yagadage digit singdo hanjanba yade number amada. We have to form 3-digit even numbers from the digits 1, 2, 3, 4, 6 and 7 without repetition. The units place can be filled up in 3 ways, either by 2 or 4 or 6. Units place to the even number tanabagi damakta apiba digit singa sigi manungdagi even number 2 or 4 or 6 amana hekta fill up to the maung ahumda fill up to yai. The remaining 5 digits as repetition is disallowed hanjanba yadrabani. Digit taruktagi digit amal even number amal thokrabadi digit mangal heuri can be filled up the remaining 2 places. 3-digit number da digit ama fill up thokrabadi places ama fill up thokrabadi digit places ani heuri up the remaining 2 places in 5p2 ways. 5 digit to the digit ani loraga fill up to that can be done in 5p2 ways ne. Therefore, the required number of 3-digit even numbers is 3 into 5p2 equal to 3 into 5p to the 5 into 4 divided by 1 into 2, that is 30 puna 30 numbers semba yagan. 4. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated. Digit manga sidagi 4-digit number kaya semba yagadage digit hanjanbagi wafam yaugdabida. How many of these will be even? Makhoi singdugi manungda number kaya na even oigadage. Number of 4-digit numbers formed by 5 digits. Digit manga sina semba yaba 4-digit number de 5p4, that is 120 semba yai. Number of 4 digits even numbers formed by 1, 2, 3, 4, 5. 4-digit the even number adudi even number ki damakta di digit manga sigi manungdagi 2 or 4 na ended oigadabani. Units place to can be filled up in 2 ways, either by 2 or by 4, and the remaining 3 places can be filled up in 4p3 ways. Simplifying, we get 48. This is the even number. Question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? Mini pandagi chairman amaga vice chairman amaga kayara khanba yagadagi mi amana post amadagi hena paiba yade haina lawrasi. From a committee of 8 persons, a chairman and a vice chairman are to be chosen in such a way that one person cannot hold more than one position. The number of ways of choosing a chairman and a vice chairman is the permutation of 8 different objects taken 2 at a time. Puthokadaba chairman amaga vice chairman amag khanbagi masing asidi object manadaba object nipandagi object ani amuk khanbagi masing duga managani. Therefore, required number of ways the 8p2, that is simplified to we get 28. 28 ways khanba yagan. Number 6. Find n if n minus 1 p3 is to n p4 equal to 1 is to 9. proportion da leriba number sing asidagi n asi putu haibani. We have this. We have learned that product of extremes matai gi ani purinabaga product of means mayai gi ani purinabaga manai. Ratio ani manababu proportion kawe. From proportion da lairabadi matai gi ani purinabagi fall 9 into n minus 1 p3 equal to product of means mayai gi ani purinaba 1 into np4 ani simanagani. N minus 1 p3 haibasidi definition gi matung ina si phangani np4 su si phangani. Hojik ani se denominator ani se manare mathak chawba n factorial c n minus 1 factorial phangnana ba phawba factorize tawro. Asumna factorize tawrabadi n minus 4 factorial denominator dagi kakhakhre n minus 1 factorial nakan animak dagi kakhakhre n equal to 9. Hence n gi value to 9 orani. 7. If find r if 5pr equal to 2 times of 6pr minus 1. Roman number 2. 5pr equal to 6pr minus 1. Roman number 1. 5pr equal to 2 times of 6pr minus 1. We by applying definition we get this, for this we get this. And 6 factorial c factorized or 6 into 5 factorial. 5 minus r ga 7 minus r ga 7 minus r na sawi 7 minus r se factorized or up to 5 minus r factorial phangde phawa. Nakan animaktagi 5 factorial 5 factorial 5 minus r factorial 5 minus r factorial kakakare. We get right side tadi 1 lehore, left side tadi 1 lehore, right side tadi 12 by factor anisi lehorani. Factor anisi ke product to som the thame 12 lede. Quadratic equation in r phange splitting middle term to gaire r value 3 or 10 r value ani phange. Therefore r equal to 3 r value se ani simanunda 3 oigani maram de r equal to 10 is invalid maram de 5 objects tagi 10 objects loba haibasi 6 object tagi object khara loba haibasi masi meaningless. 10 objects loba haibasi meaningless. Again, for Roman number 2, 5pr equal to 6p of r minus 1. Applying definition, for left we get this, for right we get this. Mathak 36 factorial na saure, kadon 6 factorial si factorize the row up to 5 factorial phangdeba phawa. Makhagi sidi 7 minus r factorial ni machina 5 minus r factorial deki saure 7 minus r factorial si factorize the row up to 5 minus r factorial phangdeba phawa. Mathak amasu makhadagi common factors sing lobthokra aduga right lemhori buduna left to 1 lehore right ki denominator cross toroga sumna phange quadratic equation in r phange factorize tore r minus 4 into r minus 9 equal to 0. That gives r is 4 or 9. R equal to 4 lorani, because since r equal to 9 is greater than 6 is invalid aiba 5 objects tagi 9 objects 6 object tagi 9 object loba haibasi meaningless. Logo ribo object to na piramibo object adugi masing digi hendo sunga yade. Maramachina r value 4 phange solve tor. Question number 8. How many words with or without meaning can be formed using all the letters of the word equation using its letter exactly once? Equation wahi gi mai pumna mak lauraga artha thokpa thoktaba thidana wahi kaya semba yagadage mayek singadu wahi amada amuktagi hena sisinaba yade. In word equation 1 2 3 4 5 6 7 8 there are 8, all are distinct different letters. These letters can be permuted in 8p8. Letter nipan sidagi letter nipan moklaroga semba yabadi 8p8. By definition we get 8 factorial ways. Therefore required number of words the 8 factorial. 8 factorial si 1 dagina 8 factorial number pumna maki product ne we get 40,320 words semba yagani article label later batidana. Number 9. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated? If 4 letters are used at a time, all letters are used at a time, all letters are used but first letter is a vowel. Monday haiba wahaigi mayek singasina artha label later thidana mayek sing asi hanjalandabida ahanbada 4 letters are used at a time. Mayek mari mari lauraga amuk ta mayek mari lauraga wahi kaya semba yagadage. Monday has 6 distinct letters. Number 1. Number of words taking 4 letters. Taruk tagi mari mari laur semba yabadi 6 before that is 6 factorial by 6 minus 4 factorial. After solving we get 360 phangani. Ani subada all letters are used at a time. Letter pumnamak lauraga semba yaba haibani. Number of words using all letters is 6p6, that is 6 factorial, which is equal to 720. Next, all letters are used but first letter is a vowel. Letter pumnamak lauba adubu ahanba mayek adudi vowel ama uhenba haibani. Vowel duna hauba hairagadi vowel si anini o ne e ne mayek ani sigi vowel anini vowel amana haukrabadi. There are 2 vowels in Monday. The first place can be filled up in 2 ways, either by O or by A. The remaining 5 places can be filled up in 5 letters. 5 p 5, that is 5 factorial. So number of words is 2 into 5 factorial, that is 240 words. 240 words. Question number 10. In how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? I marisi pulapunna samina handabida Mississippi wahida yauriba mayek singasina distinct permutation manadaba permutation kaya semba yagadage. Let us see. There are 11 letters in Mississippi, of which I appears 4 times, S appears 4 times, and P appears 2 times. Number of words formed by all letters is 11 factorial divided by I is repeated 4 times, therefore 4 factorial into S appears 4 times into 4 factorial. P is appear 2 times 2 factorial. Makoi ki product repeated ki factorial singi product na 11 factorial divide toroga phangbo word to again. Let us treat 4 I's as 1 letter. I maridu letter amakhakta oina treat torosi. Then we are left with 8 letters. I koi da mayek tarama thoidegi mayek mari lokthokhrabadi mayek 7 lehuri. Mayek mari duna mayek ama oina amuk mahut mayek ama sarabadi. I koi da 8 letters. I shikamna phange 11 dagi mari loktokhrani plus 1 hapsingani 8 letters se phangani. Number of words such that 4 I's are together. I mari du pulap na punna saminaraga semba yaba wahi masing adudi 8 factorial by 4 factorial into 2 factorial. Karigi 4 factorial, S appears 4 times, P appears 2 times. Therefore, require number of words such that all 4 I's are not together. I maridu pulap punna samina bayadaba samina daba wahi masing adudi mataki I mari thangnaba I ahum thangnaba ani thangnaba ama thangnaba amata thangnadaba singi masing asidagi I mari pulap thangnaba si khaidokhrabadi lemhauriba arrangement singi masing adu I ahum thangnaba yaurangmani I ani thangnaba I amata thangnadaba mayam loini yauramani madu oirani. There is 11 factorial by 4 factorial, 4 factorial, 2 factorial minus 8 factorial by 4 factorial into 2 factorial. Factorize common factors in loctocracy as soon as simplified taurani we get a number that is 33810 asipang masina putokadaba I mari pulap na thangnadaba what masingdoni. 11. In how many ways can the letters of the word permutations be arranged if the words start with P and end with S? Permutations wahigi mayek singasina P na hauraga S na loiba wahi kaya semba yagadagi ahanba wahang. There are 12 letters in the word permutations, of which T appears 2 times and 5 are vowels. Number of words start with P and end with S is number P na hauraga S na loiba. Mayek 12 ki manung da letter ani si fix tau thokhrabadi mayek tara khakta nga haure. Tara do na different ways to arrange to we aba masing di 10 factorial by 2 factorial. 2 factorial asidi 2 do 2 times repeated ani rakhanjana yaubugini we get 1814400 have a number si fange. Roman number 2 vowels are all together. Vowels sing si pulap punna samin halo haire. Vowels si 5 letters ni. 12 letters tagi vowel manga si logthokrabadi 7 letters lehuwi. 7 letters to the 5 vowels na letter ama on treat tawra abadi 12 tagi 5 logthokra 7 7 the 1 8 toksilabadi 8 ni. Treating 5 vowels as one letter, we are left with 8 letters. 8 karana phangi 12 tagi 5 vowels logthokrabadi 7 consonants lehore 7 consonants the vowel manga dugi na mayek ama on treat toksilabadi 8 surani 8 letters lehore. Number of words formed by 8 letters. 8 letters na semba yabadi 8 factorial by 2 factorial. Karai degi 2 factorial lemhori ba mayek sindu ti do anirak khanjale. The 5 vowels can be arranged among themselves. 5 vowels to makoi pulap no any arrangement kudimak ta satpani. Atai letters in consonant do rearrangement amada consonants in the fixed or amada 5 vowels aduna arrange tawu matamda 5p5 there is 5 factorial arrangement nama chung to e 5 vowels to now arrange in its permutation above permutation sida 5 vowels to makoi manga gi manungda arrange tawada 5 factorial ama chung thore e. Therefore number of words so that all the vowels are together. Vowel manga du pulap punna saminaba wahi masingdudi arrangement amana 5 factorial puthok labadi 8 factorial by 2 factorial number siga purinaraga 2419200 phangi masiga achoban number asina vowel manga do pulap punna samina hanba yaba word masing. Roman number 3 P and S can be placed in the following positions. P amasung S asigi marakta makhage asumna P amasung S asigi marakta mayek ani changhanba asumna arrange tawba yai. Firsta 1 and 6 1 P na first place ta thamaga S na 6th place ta thamadi mayek marakta second third fourth fifth mayek mari fill up tawba yai. Ani subada P na ani subada thamaga S na taret subada thamadi marakta mayek mari ama enter tawba yai. Mong ani ama phange ahum suba mong dana P na 3 da thamaga third places ta thamaga S na 8 places ta thamabadi marakta mayek mari ama fill up tawba yai. Mari suba mong di P na 4 suba places ta thamaga S na mapan suba places ta thamabadi marakta mayek mari ama enter fill up tawba yai. Manga suba mong di P na manga suba da thamaga S na 10 da thamabadi marakta mayek mari ama fill up tawba yai. Taruk suba mong di P na taruk suba da thamaga S na 11 suba thamabadi marakta mayek mari ama fill up tawba yai. Hauzik mong taruk phawbadi phangli. Next uthokpa yabra 7 P na 7 suba places ta thamaga S na 12 suba places ta thamabadi marakta mayek mari ama fill up tawba yai. Next position di karigumba P na 8 suba da thamurabadi S na 13 da thangodabani marakta mayek mari hapchinanaba but mayek tara thoi yawbada tara hundu suba places habisi leitrabanina hojik P na starting tawraga S na loiba marakta mayek mari hapchinba sida khoina mong taret phange. Karigumba P ga S ka interchange tawrabadi P ga jaga singda S thamaba S ke jaga singda P thamabadi maduna su amuk mong taret amaga chongthokani pulapuna 7 plus 7 there is 2 into 7 de 14. There are 7 ways hojik listing tawba sida 7 ways phangre. Similarly P and S can be interchanged in 2 ways. Haibadi P ke jaga da S thamaba S ke jaga da P thamaga sumong amaduna amuk taret ama chongthora ani. So P and S can be put in 2 into 7 there is 14 ways to arrange tawba yai marakta mayek taret mari hapchin nabagi damak. Let us take one permutation from 14 and arrange in 10 factorial by 2 factorial ways. Hariba mathaki 14 ways asidagi permutation amakhak laukasi madugi arrangement asina oithokpa yariba se mayek kaya laikre mayek ani duma fix tawkre mayek tara ni thoigi manungda ani ama fix tawthokrabadi mayek tara kaktanga hare tara don or khairaga semba yabri 10 factorial by 2 factorial karai degi 2 t asi ani rak hanjanbagi amana asi puthoklabadi therefore number of ways by 14 na puthokpadi 14 into 10 factorial by 2 factorial that is 7 into 10 factorial haibadi 2540160 achauba number sima phangani. Thank you for watching video.